Today is the first lesson for trigonometry, and we're going to start with learning right angle triangles and special angles that occur with right angle triangles. We'll learn a little bit about how to use our calculator, and specifically we're going to focus on acute angles, meaning angles between 0 and 90. So here is an example of a right angle triangle, and what we do is we put an angle symbol. So this is our theta symbol in the bottom left corner. From that angle, we can identify the sides of each triangle. So the side connecting to that angle is called the adjacent. The side opposite of the right angle, which is our 90 degrees, is our hypotenuse. And then we have our opposite side from the angle, meaning that that side is not touching the angle that we're talking about at all. There are 6 ratios that you need to become familiar with, and they all are in reference to the angle in the triangle. So if the angle is in this bottom left corner, sine is equivalent to the ratio of the opposite side over the hypotenuse side. Cosine is equivalent to the adjacent side over the hypotenuse side. Tangent is equivalent to the opposite over the adjacent. Now, those you may have seen before. You may have even heard someone reference before Soh Cah Toa. And what that is a quick acronym to remember the ratios. So for the sine, which is the capital S, then we have opposite over hypotenuse. So Soh Cah Toa. I think I said saw. Oops. Soh Cah Toa. That may be my Canadian accent coming through. Now, over here on the right-hand side, we have the reciprocals of each. So reciprocal means that the numerator goes to the denominator goes to the numerator. So this one's going to be hypotenuse over opposite. This one's hypotenuse over adjacent. And this one's adjacent over opposite. And yes, you are going to have to memorize those. So here is the actual words written out, but it just duplicates what I just talked about. So here's an example of a question. The one thing I want you to notice is that there's many different Greek letters, and those Greek letters are referencing the angles. So if we have a right angle triangle and Soh Cah Toa only works for right angle triangles, then depending on the angle in question, we need to show the ratios. So find the 6 trigonometric function values for A, which is our B value, and then our alpha. So first it's saying, let's do this for B. So sine is always going to be opposite over hypotenuse. So here's our B. That means that we have opposite. This would be our adjacent, and this would be our hypotenuse. So all we're going to do is fill in the blanks. Opposite is 12, and 13 is our hypotenuse. Cosine is A over H, meaning adjacent, which is 5, over hypotenuse, which is 13. Tan is opposite over adjacent. So again, Soh Cah Toa. Opposite of beta is 12. Adjacent is 5. Now the last 3, and I'm just going to change these all to be betas because that's what the question is asking. So cosecant, this CSC, is the reciprocal of sine. So I'm just going to make this 13 over 12. All I'm doing is flipping it. Cosine and secant are the reciprocals of each other, and you will need to memorize this. And tangent and cotangent, so we have 5 over 12. How I remember this is that the S goes with the C, and the C goes with the S. And then tangent and cotangent, they share the same word. So here is a summary of the reciprocal functions. So cosecant is the same as 1 over sine, secant is the same as 1 over cosine, and cotangent is 1 over tangent. Now let's do the same thing for our angle alpha. So the angle that we're talking about is in the top. So that means what it's going to do is it's going to change. Our opposite is now the 5. Our adjacent is now the length attached to the angle we're talking about, and our hypotenuse is still going to remain opposite of the 90 degrees. Then we go through each of our trig functions. So sine is opposite over hypotenuse. Now it'll be 5 over 13. Cosine is adjacent over hypotenuse, 12 over 13. So all we're doing here is we're coming up with ratios of the sides in a right angle triangle. And again, this only works for right angle triangles. Cosecant, remember, the S of sine, the S of sine goes with the C. So we have hypotenuse over opposite, which is 13 over 5. Here we have 13 over 12, and here we have 12 over 5. Now our next example is very similar. It just doesn't give us that right angle triangle. So I'm going to start by drawing the right angle triangle, and I'm going to draw in the angle in question. And it's giving us information. It's saying that sine is equivalent to 4 over 5. Well, I know that for a right angle triangle, that means that the opposite is over the hypotenuse for sine. So cosine, is 3 over 5, and tangent is 4 over 3. And then it's asking us to find the other 3 triangles. So if I'm going to set this up, then I put my angle in whichever of the 2 remaining angles I have, because I know this one is 90 degrees. And this means that my opposite is going to be 4 and my hypotenuse is going to be 5. So my opposite is 4, my hypotenuse is 5. For cosine, adjacent over hypotenuse. So adjacent is here. Now, did I even need to do this? No, not really, because I know that if I already have sine, cosine, and tangent, I actually also have cosecant, secant, and cotangent, because they're just the reciprocals. But I wanted to give you a visual. So 5 over 4, 5 over 3, and 3 over 4. Now I'm going to go through what we call special triangles. Now I already have this filled in for you because I just want you to follow along. Special triangles are all 90-degree triangles, and they are specific to, the first one we're going to talk about is our 45 degree. So knowing that a right angle is 90, and if one of the other angles is 45, then by definition of a triangle, the last angle must be 180 minus 90 minus 45. So when we have a right angle triangle that has an angle of 45, that means that the 2 angles are 45. Now, what that also tells us is that the lengths have to be identical. So if this angle here is 45 degrees, the opposite length, I can just arbitrarily say that that's a unit of 1 unit. That means that across from my other 45 degrees, that also has to be 1 unit long. Now, how we get the root 2 is by using the Pythagorean theorem, because it's a right angle triangle. 1 squared plus 1 squared is the hypotenuse squared. So we have 2 is equal to the hypotenuse squared, and that means that the hypotenuse is equal to the square root of 2. So what we say is that for our 45-degree triangle, we have a 1, 1, root 2 lengths for our sides. So that means that if we're going to find the sine of 45, it doesn't make a difference which 45 we're looking at. opposite is going to be 1, hypotenuse is going to be root 2. And then we rationalize it by multiplying the numerator and the denominator by root 2. Cosine is going to be adjacent over hypotenuse. So it actually ends up being the same answer. And tangent, opposite over adjacent, will be 1 over 1. Another one of our special triangles is our 30 degree. Now this one, we have 90 degrees. If one is 30 degrees, then the other one is 60. So what we're going to say for our 30 degrees is that the length opposite of the 30 degrees is going to be 1 unit. I'm telling you that the length across from the hypotenuse is 2 units, and then we can find the length opposite of the 60 degrees, again by using Pythagorean. So 2 squared, which is our hypotenuse, is equal to 1 squared plus, I'm just going to call this r squared. So we end up getting 4 is equal to 3 plus r squared, is equal to 1. Bring the 1 to the other side, and I get 3 is equal to r squared, so r is equal to the square root of 3. So we call this for 30 degrees our 1 root 3 and 2. Now, what you need to know is that the square root of 3 is approximately 1.8. So it's a number in between 1 and 2. Now this makes sense because the longest angle, or the largest angle, which is the 90 degrees, should have the longest side opposite of it. So for my 90 degrees, I have the 2 opposite of it. For my 60 degrees, which is my middle angle, I have root 3 opposite, which is 1.8 approximately. And across from my 30 degrees, I have the shortest angle opposite of it. Now, then I'm going to go and find my sine, cosine, and tangent. So for 30 degrees, my opposite is going to be my 1. Adjacent will be root 3, and hypotenuse will be 2. So opposite is O over H, which is 1 over 2, A over H, and tangent is 1 over root 3 and then it's rationalized. The next one is our 60 degrees, which is exactly what we just did. Notice that across from the 60 is my root 3. Across from the 30 is 1. Across from 90 is 2. So the only thing that's different here is that our reference angle is now 60. So it's changing. Our root 3 is now going to be opposite. Our 1 is going to be adjacent. And our 2 is going to be hypotenuse. And then we finish with the Soh Cah Toa. The last question is a word problem. We have a hot air balloon that begins to rise, and the ground crew drives 1.2 miles to an observation station. The initial observation from the station is estimated at an angle between the ground and the line of sight to the balloon to be 30 degrees. Approximately how high is the balloon at that point? So let's first start with a beautiful picture. So we have the balloon that's going vertical, and then we have the car that's driving at that 30-degree angle to the line of sight of the balloon. And what we're going to do is we recognize that we're given 1.2 miles. That's the distance that the car drove. Once we've identified that, we can see that to the reference angle given, this is our opposite side, which is our height, which is what we're trying to find. Here's the hypotenuse, and here's the adjacent. So the question is given the fact that we're trying to find the height, which is our opposite side, and given the fact that we're given our adjacent, we have to choose the appropriate trig function. So notice that the hypotenuse is not being used. So we don't need to use sine, and we don't need to use cosine. So we use tangent, which is opposite over adjacent. We fill in what we know, and then we just rearrange. So we're going to multiply both sides by 1.2, and then in our calculator, we're going to enter 1.2, hit the tan button, and 30 degrees. And that gives us approximately 0.7. The other thing that we can do is recognize that tan 30, if we go back to our special triangle, tan 30 is equivalent to root 3 over 3. That's the ratio. So we can also look at it like this is really 1.2 multiplied by root 3 over 3.